Okay, deciding to do another one. We're going to do number 1 here. So consider the following reaction. You got 2 moles of aluminum plus 6 moles of hydrobromic acid, or just HBr, and that will produce 2 moles of aluminum bromide and 3 moles of hydrogen gas. So let's just start here. We got 3.22 moles of aluminum, and it reacts with 4.66 moles of this. How many moles of this can you make? So what we're going to do first is figure out if you have a certain amount of aluminum, how much of this do you get? And then using a different color, we'll figure out, okay, if you have a certain amount of this, how much do you get? And we will compare those numbers. So let's do the aluminum first. So 3.22 moles of aluminum will produce, now we got to do a molar ratio, right? This relationship, molar ratio between the two things. It is 2 moles of aluminum will produce 3 moles of H2. So how many moles will we get? Well, now I got to bust out the old calculator. So 3.22 times 3, take that number, divide it by 2, looks like 4.83. So 4.83 moles of hydrogen gas. Now let's compare HBr and H2. We got 4.96 moles of hydrobromic acid. You don't have to know that that's what it's called, just HBr is fine. And then in this case, the molar ratio is a 6-to-3 ratio. So 6 moles of HBr will produce 3 moles of H2. And now really it's just 4.96 divided by 2, right? I mean, if you just reduce in your head there. So 4.96 divided by 2, I really should be able to do that in my head, 2.48. So 2.48 moles of H2 gas. All right. So it looks like that this one right here is less. So this is how much you're going to be able to produce. You're only going to be able to produce 2.48, right? Because it doesn't matter how much of aluminum you have, you're going to run out of HBr first. So how many moles of H2 are formed? 2.48 moles of H2. That means that HBr must be your limiting reactant because that's what you're going to run out of. That's the thing that produces the least. So this is going to be HBr. And so now just, again, take a pause here for a second and just think logically what's happening. We have these two ingredients. Oopsies. We have these two ingredients here. We got aluminum and we got HBr. And we are going to run out of this one first. So there's going to be some leftovers of this. And the question is, how much leftovers will there be? Well, let's just start by calculating. So we have 4.96 moles of HBr. How many moles of aluminum will react with that? Well, the molar ratio between these two is 6 moles of HBr needs 2 moles of aluminum to fully react. So it's really just 4.96 times 2. Take that number, divide it by 3. So 3.31 base. I'm just rounding, but 3.31. 3.31 moles of aluminum. Did I do that one right? Times 2. 4. Divided by 3. Oh, I'm sorry. Should have been divided by 6. I'm going to pause right here for a second. My bad. Let's go back to that. So I typed it in wrong. So 4.96 times 2 equals divided by 6 equals 1.65. Okay, there we go. Much better. 1.65 moles of aluminum. The other number was too high. It was actually more than the 3.22. So I knew that we must have had a problem there because we're supposed to have leftovers. So anyways, now we just figure out how many leftovers we have. We started with 3.22. We used up 1.65. And then just do a quick subtraction. So 3.22 minus 1.65. We got 1.57. We are going to have 1.57 moles of aluminum left over. 1.57 moles of aluminum. So now let's just double check our answers. We can even just go down to here. This was number 1. 2.48 HBr 1.57. So we had 2.48 HBr 1.57. What did we say? 2.48 HBr 1.57. We're good. And again, that's how you do these.